I'm delighted to have you as part of this community. Welcome, welcome, welcome. We extend a warm welcome to you as we discuss and analyze Zenith Cable Modem in this video. Zenith Cable Modem was one of the first proprietary cable modems. The two basic models are one operating at 500 kilobits per second bits, and the other at 4 megabits per second bits with BPSK and approximately a 25% alpha. As we enter this new phase, let's uncover the impact of history on our broader topic. The Zenith Cable Modem was originally developed for a mid-split cable network in the mid-years. It was used as an 8-bit full-height JIT-type card containing an Intel 80186 dedicated CPU, connected to an external white box about 2x12x6. Other similar products were made by German-based UB under the Abroad standard and Vitalink. UB had models supporting RS-232 and Ethernet outputs, as well as a ray-modulating frequency translator. In late 1993, Zenith Electronics and Prodigy provided 12 modified 500 kbit white modems to Cox Communications in San Diego, including 2 with IBM microchannel support. These modified modems were intended to support the Prodigy Cable Modem trial, which began on a 1500 homes passed fiber node in El Cajon, CA. The modification allowed subsplit operation, with a fixed upstream frequency and a downstream at 74.75 ms, within the forms space between analog channels 4 and 5. The initial trial consisted of a Prodigy server in the El Cajon headend, connected via the microchannel-based cable modem to an Olsen frequency translator. This basic network supported the 1500 home passed fiber nodes, with 6 subscribers including 1 employee of Cox, who was also the head-end manager. 1 card was installed in rack-mount PC in the Federal headend, another in the El Cajon headend. 1500 high-pass filters were installed to eliminate any ingress from the drops. Service was reasonably reliable. Zenith updated their white modems to a matte black case, adding the HomeWalks name and marketing to cable operators at the $350 price range for 250 units. The new design used the same size external case, added LEDs to indicate PARX activity, and replaced the full-sized 8-bit ISA card with a smaller 16-bit version. The new design dropped the onboard CPU. The modem connected to the card used a 15-pin D-shell connector which exactly matched the PC's game connector. Both models were powered by the PC. The new modem was frequency agile, with a configuration utility that ran on the PC to set up US and DS frequencies. The option to configure the card's MAC address was soon dropped. However, the card's MAC address was not printed on the outside of the board, and thus was invisible once installed into the PC. Nor was the MAC address printed in a machine-readable barcode format. Cox added these to the CM prior to installation, and tracked the subscriber to modem MAC address in an Excel spreadsheet, as the MAC address contained too many digits to fit into any fields within the customer billing system. As we venture forward, let's examine product versions in detail and gain a deeper appreciation for its significance. White modem, from as base design black internal modem, HomeWalks external modem, 1 Ethernet jack external modem, 2 Ethernet jacks HW revision A, first black case modem HW revision B, volume production of an estimated 7,501,000 units for shipment to 810 cable operators HW revision C, introduced a 2-board model and 4-tall case that would allow use with a traditional Ethernet-based T connection instead of an internal PC card. The external models used an RJ14 style phone jack for serial control, configuration, and management using a Zenith-supplied utility application. HW Revision D eliminated the susceptibility to RF interference from nearby cell phones. The fault caused the transmit side phased locked loop PLL to fail. Resolution required a power cycle. Fault was non-detectable in software other than no connectivity. HW Revision E introduced dual BPSK interface for University of California, San Diego, and other customers. Added modem MAC address to external CM, and in a barcode-readable format. All Zenith modems contained a small switch controlling the second coax port. The modem could either operate on one coax built-in duplex filter or two hidden use dual plant networks, or external duplex filter. The initial Zenith hidden design was to use a residential cable modem inside a server, and a frequency translator to convert the upstream transmit frequency to the downstream receive frequency. This design did not scale to more than a few networks, so the channel miser was introduced a 2.5 tall rack-mountable device with separate US and DSRF ports, the duplex filter switch, and an Ethernet port. The first large-scale Zenith hidden was constructed in Cox, San Diego using Zenith's booth demonstration hardware from the 1994 Western Cable Show. 3 frequency translators, plus 4 channel misers were installed in El Cajon. These plus 3 other channel misers were interconnected to an 8-port Cisco Catalyst 1200 Ethernet switch with single-mode FDDI uplink for a 4-device, 140 FDDI ring around San Diego County. The Prodigy server obtained a traditional Ethernet card. The 7 frequency translators plus 7 channel misers supported 65,000 homes passed on 23 fiber nodes, and occupied a full rack. In this segment, we'll be unraveling the complexities of technology demonstration to initial deployment and exploring its multifaceted nature. Prodigy was deployed over cable modem to 200 users in time for the 1994 Western Cable Show. To grow the system from 16 users in 3 fiber nodes to 200 required adding what became 64,000 homes passed, making the Cox San Diego Prodigy cable modem field trial the world's largest cable modem deployment by service area at the time. The acceptance criteria were too strict to achieve the 65% homes passed high-speed internet penetration, which is common to a Prodigy subscriber greater than 9 months cable subscriber bid in two-way activated area open slot in 80,386 based PC or greater willingness to participate when called between December 15, 1994 and January 3, 1995. The result was a population of 1% of the homes passed, or 64,000 homes passed for 150 users. At the time, two-way communication over this surface area was assumed reliable given that two-way impulse pay-per-view cable boxes were deployed to these same places. The Pioneer set-top boxes used FSK, retransmitted up to 32 times over 3 days, and worked for up to 5 purchases without a return path. In the next segment, we'll be exploring the Zenith MAC layer and its implications for our subject matter. XMIT, or Ethernet-like, was expanded by reducing the data rate to 500 kbits for up to 5100 miles plant radius and to 4 bits for up to 25 miles plant radius. The transmitting device first listened for activity. If there was activity, it would activate the LED and wait. Activity is defined as any RF energy, intelligible or not, at an absolute amplitude of -25 dB into the device receive port within a 1 or 6 passband bits or 4 bits respectively. Upon detection of no activity, using appropriate backup timers as per Ethernet XMIT standard, the CM transmitted a preamble followed by the start of the Ethernet frame. Simultaneously, the transmitting CM would begin listening for its own burst. If the CM were able to decode its own burst and correctly compare a checksum of the first 17 bytes of the packet, it would declare no collision and continue. If there was a checksum error, it would declare a collision and stop transmitting after the 19th byte. This was easily and directly measured using Novell Analyzer software on a dedicated Windows 3.1 for Workgroups PC. The card kept some locally accessible counters on excessive and late collisions, but there was no driver or management. By November 20, 1996, Zenith released SNMP MIBs and management for their channel miser under software release 9.32. under the title Node Data Controller SNMP. Get ready for an exciting exploration as we unravel the mysteries of provisioning. The physical possession of a properly installed modem connected the subscriber to the network, and the use of this modem with a packet sniffer would enable full viewing of all transmitted and received packets from every user sharing that frequency translator. Removing a device for non-payment required physically retrieving the device and preventing the availability of used or stolen modems. Modems could not be disabled remotely. Now, we shift our focus to quality perceptions and reality, a topic that deserves our attention. While not directly competing against an existing product, residential ISDN penetration was sub 0.1%. The technology had severe growing pains. The team identified 19 independent causes of 2 RSET 9 and CT16. A communications failure has occurred. In the following section, we'll be immersing ourselves in the captivating world of driver software. IPX driver not loaded when launching Windows IDNX 56 bits link from local Prodigy server in El Cajun hidden to Yorktown, NY, was down. Prodigy's server in El Cajun hidden experienced driver wedge due to excessive noise in return path and inability to transmit packets. Call Prodigy and request server reset. Duplicate CMMAC address lost. Modem frequency configuration. Traffic storm. ARP storm. Excessive traffic of any kind or an ARP storm would shut down the network. Fastest resolution was often to take the network down and reboot the affected systems. Often required calling the customer on the phone and asking them to do so. In this chapter, we'll be shedding light on modem hardware and its role in shaping our understanding. Cell phone use near the cable modem, PLL unlocked, power cycle to resolve channel miser lockup. Cell phone use near hidden cable modem, PLL unlocked. Power cycle to resolve frequency translator drift. Resolution. Replace the Olsen unit with model made by Wacom Now Vecima Networks, who now makes up converters for the Cisco DOCSIS compliant CMTS platforms. Diplex filter switch got bumped. Modem module disconnected or plugged into PC game port instead of modem card. Less of an issue with black modem as LEDs would go dark, but impossible to verify on white modem without LEDs. Now let's delve into the intricacies of RF and explore its various aspects. LRC STS75 end-of-line terminator causing common path distortion. CPD. A mechanical design defect occurred when a 22-gauge piece of stainless steel wire was press-fit into an aluminum housing and compressed to become watertight. Unfortunately, corrosion developed anyway, and the resultant diode from dissimilar metals caused the CPD. Resolution. Replace 10,000 units at a part plus level with gold anodized model. Return path alignment and hidden combining. Independently develop the X-point return path alignment and amplitude compensation process. Due to the amplitude modulation AM format of the return path FP lasers, a 25 CW tone injected at the fiber node status monitoring module would not arrive at the hidden with constant amplitude. Add inputs to frequency translator to ensure 5 input on this tone for each fiber node individually. Filter corp brick wall filter on the output path to the frequency translator was too sharp, introducing excessive group delay. PCS cable telephony trial precision CW clock distribution tone at 73.25 jamming subscriber transmitters, causing a light on solid and 100% collisions. Poorly chosen upstream frequency for white modems, resolved for deployment of black modems. Too many homes passed per frequency translator. Worked reliably with 8,500 to 10,000, but much better at about 6,500 homes passed. Speaker modulation. When the coax connector on a nearby television set is loose, and the audio is really loud, the mechanical vibration of the television set alters the physical connection of the coax, allowing ingress and other interference. Missing return path amplifier. During the early days of the trial, few repair trucks carried return path capable amplifiers. One amplifier was replaced with a one-way amplifier and improperly noted. Without further ado, let's move on to the topic of RF requirements. Carry anything of at least 25 kbit the receive portable modems. To support the time-varying nature of an HFC network, 35 kbit anything was required at the input to the frequency translator in the headend. Carry anything includes noise, interference, and distortion products. Downstream input to each cable modem of 5 kbit 2 kbit. Due to the non-existence of any real input AGC, the lack of array modulating frequency translator and lack of upstream transmit power control, the tight receive level range accommodated upstream path variation. In comparison, a 2003 DOCSIS2 compliance CMTS operating at 0.5 to 1 from theory to provide both ECAM and 64 QAM in 6-point forms at 25 dB noise, and in some cases negative Chi. Next gens. Prepare yourself for an eye-opening discussion on RF plant maintenance in 19,941,995 in the upcoming portion of this video. An HPR low-cost version of ERC video out connected to a Kaku channel modulator operating above 515s, with a Radio Shack black and white TV picture tube tuned to UHF channels to see the picture. Add to that a cone generator with 46 CW tones, an HP Kalen 1776 portable spectrum analyzer. Not all amplifiers contained a good return path test point, so the repair lab was asked to modify some line extended duplex filters to pass the forward and divert the return path to an Fahrenheit connector. A pad socket was also converted. Any signal entering an amplifier with an amplitude above -45 dB was located and fixed. CLI was reduced to under 5 ohm. 2 years later, Milo Medine, CTO of Home, was reported to have said, "Please show me the fiber receivers that are connected to the outside plant. These don't have enough noise, so they are certainly not connected or properly aligned." Later, he was quoted as saying Cox San Diego return plant is so clean you could eat off it. San Diego never had serious RF issues when it came to return path after 1995. In this section, we'll be shedding light on Network Operations Center NOC and its impact on our understanding of the subject. Network Operations Center NOC. Modeled after the University of California, San Diego Telecommunications NOC at the Central Utilities Building, Novell Analyzer Software W internal cable modem, and a technician to manually move the test connection between frequency translators. Only one frequency translator could be measured at a time. HP OpenView HPOV and a 24-port HP Advanced Stack Ethernet HUB with AUI uplink was available. This combination allowed the Advanced Stack hub to send out IPX diagnostic packets to the NDIS driver in each PC. Assuming the PC was running the driver at all times, the HP OpenView application would display the network device ID 0, MAC address, as there was no real network server router. The management software would generate NDIS diagnostic pings from the hub and report the number of successful responses. Rebooting the PC, loading and unloading the driver, or experiencing RF faults would cause each cable modem to transition from active to inactive hundreds of times per day. HPOV could export the log file to a Paradox database for later analysis and trending, eliminating the PC reloads and driver reloads from the RF faults, and correlating RF faults on a single frequency translator versus the entire flat network was not available. These methods became the justification and fundamental research for what was later patented by others, and eventually, this technique became mandatory in DOCSIS3, although it was rejected and ignored for 3 years as a proprietary extension to DOCSIS by Home and copied by every DOCSIS CMTS vendor. By September 1994, the NOC was expanded with the introduction of 2 at Cisco Catalyst 1200 Ethernet to FDDI switches, and 2 at Cabletron MMAC3 FNB hubs 6 Ethernet plus 2 FDDI constructing a reliable path from the federal headend to the LKGen headend, and eliminating one unreliable path between the advanced stack hub and the various channel misers and frequency translators. Get ready for a captivating exploration as we unravel the layers of video conferencing over cable modems in 19,941,995 and their profound significance. Qasim and Apple QuickTime Conferencing 1 beta ran over the Zenith and Lancity proprietary cable modems when the RF path was sufficiently clean. These modems were able to interoperate on the same RF fiber nodes using frequency division multiplexing, using an Ethernet switch to join the otherwise incompatible networks. Late in the beta, 160x120 pixel video was increased to 320x240, and the audio quality greatly improved on the Apple Palm Macintosh 7100 AV. As we move forward, let's uncover the untold stories and fascinating intricacies of Cogeco. Cogeco in Canada launched with the mbits external RevD cable modem in roughly 1996, and by August 1997 had 2,500 subscribers. The network experienced failures for 3 reasons. The Zenith network is a pure bridged XMPT Ethernet. It has no understanding of the Layer 3 ARP protocol. Thus, ARP storms through the Layer 2 switches used in the first hidden designs would clog the network. The Layer 2 switches and Layer 3 routers of the time did not perform any QoS or rate limiting, thus a mbits input port on the channel miser could be flooded with up to 10 bits of traffic bursts. The Cogeco network contained an unusual reverse path amplifier as part of the retrofit to accommodate return path. This amplifier contained a design defect whereby the pad and equalizer plug-in modules would literally fall off the circuit board when the device was opened. A thermal incompatibility existed, causing the holes for the parts to increase in diameter, while the pins would elongate and become smaller. This fault was documented and proven as a result of Cogeco's first DOCSIS deployment with the Cisco ABOMEC FPG aligner card and iOS earner, which contained the flap list. Thanks for being a part of this amazing journey. I can't wait to bring you more exciting content.